He's joining from a different time zone as well. This is literally the
Yeah.
event with the biggest outreach by GDG Cloud Sudbury. Of course, we appreciate all the attendees from Canada, of course, but shout out to the people who are joining
Really?
from other
Yeah.
countries.
Yep, indeed. I believe it's pretty late in the evening in India as well.
Is everyone here done with filling out the Google form?
Yes.
Okay, perfect. Sounds as good a time as any to get started with the presentation. Take it away,
Cool.
Pragith.
All right, thanks, Aditya. So hello again, one more time for someone who joined recently as well. First and foremost, thanks for joining us on a Saturday. Hope all of you are keeping well during these uncertain times. My name is Pragith, and I work as a data science consultant with Cardinal Path. And we are a group of agencies under Dentsu Aegis Network who work on primarily in advertising and media. So I belong to a team of data scientists who work on media analytics data. We try to build sense out of the digital media data that is captured through Google Analytics, Adobe Analytics, and similar tools, and we try to improve the business of our clients through whatever data that we have captured. So that is my professional background. My personal background is I am living in St. John, New Brunswick. Right now, very recently, I've started into completely remote work now. So so yeah, I think it's going to be a very fun adventure in this as we are adjusting to this new remote workplace work culture. So having said that, let's move on. So in today's talk, we'll try to understand and focus on the industry perspective of data science. So although most of us we would have come from different backgrounds, and we would have um, at least in some point in time come across some article or some definitions or some video on data science. So just to make sure that I have brought everyone into the same level of understanding of the term data science. So of course I'll be talking about the definitions, but after I talk about the definitions and essential things, I'll be moving towards the industry experience and what my experience has been of working across different sectors, business sectors, and well, I'll just share my experience, and if you like something, maybe that can help you out, and maybe let me know if you have any questions, and we'll take it forward. So before I jump, I just want to do a quick voice check and video check. Is everyone able to hear me properly? Is everyone able to see me properly? Is everyone able to see the deck also properly? All good? All good? Aditya?
Yeah.
All good, right? Cool. All right. So let's start by defining data science. Again, like I said, a lot of you would have come across different definitions. You may have even come across some arguments that happen on LinkedIn threads or comments. People who belong to who come from a specific discipline of education, they have their own definition. People who are not that close to certain disciplines of academic background, they have their own flavor of definition. So we will see all the definitions, and we will also come up with our own. Let's see what makes sense to us, and what the industry, again, like I said, from industry point of view, what the recruiters are trying to see, because you always have to jump through that recruiter firewall, right? Because you may be an excellent candidate for a specific job role, but if you cannot jump through that firewall, if you cannot not jump, at least pass through the firewall, you may be missing out on a lot of good opportunities, and even the company would be missing out on a good candidate like you. So let's try to understand from industry perspective as well. So the usual definition of data science is that a person having all the three skills of computer science, maths, and statistics, and business acumen or business expertise. They a person who has good amount of experience in all these three things is apparently called as a full stack data scientist. A full stack, you could say, is borrowed from the web developer or developer nomenclature, but that is also used for data science these days. So someone has, and you can see how the Venn diagrams intersect over the two circles, and there's a job opportunity that comes from that itself. So if you are someone who knows programming and you are good at math and statistics, then you are an ML engineer or machine learning engineer. If you are very good with analysis, just you have that skill within you, um, by looking at the numbers, if you can come up with some meaningful insights for the business. So that means that you have the business knowledge, and since you're playing with the numbers, so that's math. So you are a data analyst because you're analyzing data. And if you are just a programmer who builds, let's say, a VBA programmer who builds macros in Excel, or small scripts for automation, automating CSV files or Excel files or some reports or things, these kind of things, then you are just a software engineer or a developer, or sort of like the go-to person for automation of these kind of things. So there are job opportunities and job roles in all these segments that I spoke about. It's not just where all the three circles intersect and it's data science. It's not just that one role. Um, a good successful data science team is a team which has a mix of all these skill sets. It's the era is still new, the discipline is still new, the academy is still new. People are coming up with more structured and more formalized way of designing the curriculum, designing the syllabus, and creating a batch of data science engineers, if I want to if I want to call it that way. So having said that, you can still fit in a data science team, a traditional data science team, even if you don't have one of these, one, or I shouldn't say more, but at least one of these skill sets you don't have, you can still fit inside a team. And like I said, there is a mix is required. You need at least, let's say, three of data engineers for one data scientist for one data analyst. So you have one data analyst, one data scientist, and then three data engineers in a team. You have a startup right there. That's a startup. That's a data science startup, because that you can implement things from end to end if you have a team like that. So make sure that you don't get discouraged or overwhelmed with all the types of skills that one feels is required. So don't let that demotivate you in any way. And we'll talk about, so if you go to YouTube, or if you just go to Google and just search the same thing, you will get this Venn diagram, and you will have plenty of learning material for the math and statistics, and even for computer science. But something that cannot be taught that easily or in a structured way is the business acumen and industry experience. And that's what, like I said, that is what I'll be focusing on in this talk. Because again, if I have to talk about Python, it'll be redundant. We can talk about Python some other time. We can also talk about linear regression, or whatever, all the ML stuff in some other time, because there are always learning materials for that. So let's talk about business and industry and all those things. However, like I said, if if you are someone who is still new to the entire picture of data science, when I said linear regression, it threw you off. When I said Python or something, it threw you off. Let's talk about that for a couple of minutes before I move on to the industry experience. So, data science versus data analysis. This is a quite often touched subject. There are a lot of data analysts already. There are a lot of data analyst jobs, really. There are chances that without even knowing by yourself, you are a data analyst already. You were not oriented with this term, or the skill sets that are required. So we already have data analysts, but if there is someone who wants to move from data analyst to data science, if they are charting their career path that way, or even if you are a newbie, if you are a fresher in the job market, and you still want to understand both the sides of both these job roles side by side, and then you want to make a career decision, well, we can talk about that also. So let's dive into data scientist versus data analyst. Like I said, I won't be talking too much about the concept. Rather, I would be talking about the same things from a job role point of view. So you have a data scientist and you have an analyst, right? So this is a very famous you know a chart which you can based on different segments or different features of a candidate or a person who would like to apply for a job role. This is a tried and tested difference between chart. So within data scientists, so of course I'll be sharing all these tech with you at the end of the talk. So you don't have to focus on reading the text on that. But on a very high level, you also need to understand, like I said, within the data science team, there are data engineers and there are data scientists or data modelers. Modelers are the one who deal with machine learning, applying the concepts, applying the stats and algorithms, and deploying them into solutions. So someone who knows or understands linear regression needs to code it, needs to apply it, whatever tools, code or use GUI tools or whatever, apply it, deploy it, and then a meaningful output needs to come out. So that is a data model. Data engineer, on the other hand, works on coding and solution development and deployment. So the data engineer focuses on ensuring the quality flow or the data flow. So when we deal with the raw and unstructured data, we process that, we massage them into a shape which is ready for the data modeler to consume and build meaningful insights on. So that is sort of like the 80% of the project of any typical data science project is data engineering, where you have to deal with data from all sorts of the place in different shapes and forms, and then you have to make meaning out of it. And then of course it goes to the data modeler, and then they apply machine learning, statistics, and other tools and techniques to build sense out of the data. And then the data that they publish is eventually sent to the data analysis team or the data visualization team, so that they can represent the raw CSV and Excel files and with all these weird column names and column format and all those things. It's their job to make represent this data into a beautiful, meaningful dashboard, report, data story, or data product. So this is how a typical this is the typical journey of a project. When a project enters into our work stream, from maybe the sales team or from the marketing team, whatever, it comes to us. We get the problem, we get the problem statement, and this is how we work. We start collecting the data, we massage it, we then we apply machine learning techniques on it, and then we publish the results in a beautiful way. So this is the typical role, and considering the slide also, if you feel that you belong in a certain place on compared to these two sites, you can start your journey from there, and then you can discover yourself. You can measure your own performance and see how you want to move forward. So just give me 1 second. I'll just have a second. I'll take all the questions towards the end of the meetup talk. So if you have any questions, please keep making a note of them, and then we'll discuss them together. So yeah, this is on a very high level, the comparison between data science and a data scientist and a data analyst. So let's focus on the science part, because that's why we are here, right? We want to demystify or understand the science part of data science. You may have seen it's again just nomenclature, right? When you're dealing with historical data, when you're dealing with data that things or events that have already occurred, you're trying to analyze historical data. Now, that is called as analysis. But when you want to talk to the computer in a language that it can understand, and you want to tell the computer to think like me, like when I say the house price, if I have to throw a question at you to ask, like, compared to a house price in St. John, New Brunswick, and compare it with a house in Vancouver or California, what would be more expensive? I'm not asking the number exactly, just the sense, the feeling of what is more expensive. You would obviously tell immediately that Vancouver is more expensive. Now, I want to mimic that experience, or the information that led you to say Vancouver is more expensive. I want to mimic that into the computer. So when I want to try to do that, I have to speak the language that it can understand. And there are two languages that it can understand. One is obviously the programming language. So it could be Python, R, Java, any language whichever has the interfaces and libraries through which you can do ML. And the second language obviously is math. There's no beating around it. You have to understand at least some basic amount of math, because because your thoughts, and like you can see on the screen also, your thoughts, your thoughts were structured with meaning and logic, that Vancouver is obviously, you see that sense, right? Oh, Vancouver is obviously more expensive. So that logic, that clarity, you need to mimic into the computer. For that, you need to know math. So it's very important. That's why it's called a science, because computer programming is also math. So they all have the same roots, and all of these were piled up and added on top of it. So computer science. So you get the science part from it, and you apply that science on data to derive meaningful insight. So there you go, you have data science right there. So that is one way how I have seen how data science is being applied in practice. Theory and practice, there are differences, I will agree, but it's not too much. So I'll get there where I talk about industry experience. So this is the definition. So let's get more into the technical skills that are required. This is my favorite slide. I've been following this since 2013. I've been trying to. I'm nowhere close to reaching all of them, but this is a good, you could say, a cheat sheet that you could print and put it on your wall, so that you can track your if you're able to. How you're able to measure your progress or your journey in learning more skills for data science. This is a bit outdated. Like I said, it's 2013. So you could still refer to it from a conceptual point of view. So if you come across, let's say it says some tool which is no longer available, or if it's no longer relevant in the job market, you can just ignore that. You can replace that with some other tools which are relevant in the market. So no hard rule in that you have to learn everything that is on the screen. But this is a good reference point that you can check. And the creator of this is Mr. Swami Chandrasekharan. He's an ex-IBMer. I've been following him on LinkedIn. I really like his posts on AI and ML, usually AI and ML. And he's also an ex-IBM distinguished engineer. So you really need to check that out, what that means. It's a pretty cool thing. So that is, rather than boring you too much about what each and every skill set here, it is just a very, very 15,000 feet overview of what the skills are required. So this is all about defining data science and understanding the skills about data science. So I hope those of you who did not know about data science, at least the definition point of view, at least now you have some understanding of what people do, or what do they mean when they talk about data science? So moving on, for the rest of the talk, we'll be talking more about industry experience, my experience, the business models available for data science, and in general tips as well. So just give me 1 second. All right. So importance of industry experience. I cannot stress this enough. A lot of people right out of their graduation, or once they are done with their academic life, a lot of people immediately jump to business or own business and starting their own venture and stuff. So it's just fine. Of course, I really encourage entrepreneurship, but what happens is, again, with respect to data science, it's very important to understand what the clients want. Who are your clients? What do they want? You you probably know how to plot a bar graph in Matplotlib, or you probably, again, using the same linear regression example, you probably know how to run fit a linear regression model in a data frame. But that is not what the client wants, right? The client doesn't want a chart. The client wants you to tell what goes into the chart. And then, of course, build the chart and give it both. So this is the problem, right? There are a lot of variables that we have to understand. And I hope I can say this: industry experience is a very good safety net to experiment with yourself and to experiment with all these things, within, of course, the confines of a professional life and professional work culture. So it is very important, and let's talk about the different elements of why I feel industry experience is very important. The first thing is putting theory into practice. Like I was just saying, you know probably how to deploy something, how to do something, how or when to use what model for what challenge. You probably know how to build a pivot table, how to use VLOOKUP and all those things. That's good. That's fine. But you need to put that into practice. But before I proceed with loading the rest of the things on the slide, you could challenge me and say, well, I am doing that. All the tools that I use are open source. All the databases that I use are open source. Well, the entire cloud is like, you can sign up for Google Cloud trial, and you have the entire cloud platform unlocked to you, and you could do anything just by sitting at home. Why should I have industry experience for that? Why are you saying putting theory into practice under industry experience? Why cannot be outside, right? And that makes sense. But a lot of times you would realize that just working on the open source tools, just clicking buttons on GCP, Google Cloud Platform, or creating a database or doing this is not enough. There are a lot of external variables that you would never imagine that just crop up, and they challenge you, and you evolve in that challenge. So we will talk about that now. So talking about that, so the first thing is hands-on live enterprise grade projects. You get to get your hands dirty with real projects, real pain problems of the clients. The client will come and tell you, this is my problem, help me. And then you will be helping them directly with some form of safety net of your organization. When I say safety net, I mean, if assuming you have taken the snapshots and backups of the work that you're doing. So the organization will provide you with the resources where you can do that, where you can safely take backups of your work. In case you screw up something for the client, you can always revert back. So you have that safety net with you. You also have people, your manager, your colleagues, your subordinates, all these people to support you when you're working in an enterprise grade project. And when you're working in a collaborative environment, that is where the true learning happens. You learn how to do things, obviously, but you also learn how not to do things, which is absolutely absolutely very important when it comes to dealing with the cloud technology, the cloud computing technology. So it's very, very important to learn how not to do things or how not to use bad practices. So yeah, so it's very important. Hands-on, live, enterprise-grade projects. Then what you do is, if you have skills in certain areas, but for specific task or for that specific project, you do not know how to apply that skill. Like I said, you know how to plot a chart, but you don't know what to plot. So at that time, you shadow team members. You sit with them, and you probably don't bill your work, or probably bill your work depending on the business model, and they do the work, and you are probably sharing. They are probably sharing the screen, or during the calls with the clients. The emails which they send to the clients, you are CCing them. So this is how you shadow them. You try to learn the techniques, and probably even about the client itself. And probably your colleague knows about the client because he has been there before, he or she has been in the organization before you. So they tell you, you know what, this client is like this client is like that. So this is how we need to approach. So it's not just the chart. It's not just matplotlib. It's not just VLOOKUP. It's also it's 360 degrees. It's a holistic development, which is what I mean by putting theory into practice. This you cannot learn by sitting at home. By that I mean the opposite of industry experience. By not having industry experience, now everyone has to sit at home. So that joke. And the next thing is your team's success is directly proportional to your success, and the opposite is also true. Because I think the opposite is what you would be wondering about, and I wrote the other way because after about 7-8 years of work experience, you come below the team. Like the team comes before you, right? So your success, or if I have to say in that way, if you're measuring your success in your yearly performance reviews, your goals that you have set, the certifications that you want to achieve, the technology that you want to learn. This year, I'm going to learn Kafka. This year, I'm going to learn Hadoop. These are the goals that you keep. And if you accomplish them, that is your success. That's how you're measuring success. So your success in a collaborative work environment is directly proportional to how well your team is doing. And this need not be the case all the time, but at least in my experience, what I've seen, this has been the case almost all the time. It's really important to understand that when your team members are happy, there's no reason why you cannot be happy. It's automatic. You will be happy all the time. So when you're working, you need to understand you need to understand where your colleagues are having pain. When you're shadowing them, try to listen to them, try to understand where the problems are, and see if you can fill those gaps with your own hacks and tips and tricks and all those things. And when you fill all these small gaps within the team, and when you build a quality solution as a result of it, well, you and along with you, your team will get all the applause. And this has happened all the time, 100% of the times. So always think about that. When you're working in a collaborative work environment, your success is dependent on your team's success, and your team's success is dependent on your success. And most importantly, the work culture. This is kind of I don't know what is the right word, paradoxical or ironic. I don't know. Because when it comes to machine learning or deep learning, we talk about feedback, right? Like you get feedback from the model, and then it learns from, and then you get the output, and then you tweak the model back, and then you get the output. So in the reinforcement learning, at least you have this feedback loop going on. This is applicable to of course human life, because machine learning is mimicking human behavior, right? And this feedback goes back into your work ethic and work culture. So when you're a professional, your behavior, your ethics, your etiquettes, your communication skills, that you show in the code, because if you're coding in Python, obviously your code looks beautiful, right? So you show that discipline in your code, you're commenting your code, you show your genuineness and your ethics and your quality in the product. That feeds back into you, and your work culture, your perspective of how you look at the problems, how you collaborate with the teams improves. And when that improves, that shows back into your work, your solution. So you need to gel with the work culture. But you could ask me what you mean by work culture. I understand the importance of work culture, but what do you mean by that? And I'll be talking about that briefly when I talk about the business models. So you need to, when I talk about the business models, depending upon which business model which suits your personality and your aptitude, your comfort level, you try to apply for the jobs in those companies or those organizations and gel with that work culture, get into that work culture. And that leads to happiness quotient of an employee. That is what makes you stick to a company. So ethics of data science is a very less talked subject, and I don't want to bore you too much with all the complicated concepts or concepts in general about ethics of data science. But you may have come across this recent news that came out where a data scientist for I think the government Florida Health Department was fired for I believe not manipulating the numbers, and that's a these things, the choice, the tough choice, the tough conversations that you have with your team, with your superiors or your subordinates. These kind of things, again, you will only encounter in an industry experience. And whatever the outcome is, I'm not here to comment on whatever needs to be done. Of course, good things. You should always be a good person, good data scientist. But whatever you decide to do at the spur of the moment, when if you are that person and your supervisor in the health department comes and tells you to do that, whatever outcome of your decision is the thing that will help you build your character and evolve you as a data scientist, or even as a professional, or a professional worker. So just be mindful of ethics. Make sure that you go ahead, Google ethics of data science and read a bunch of articles about it. Try to understand what is right, what is wrong. Um, if you feel that something cannot be told to your supervisor, if you did something and that cannot be informed to your client, or if you think that you did something and it cannot be informed to your supervisor, then that is probably a bad thing to do, and you should avoid it. I think that's a simple formula that you can use. The next reason, or the importance of the client, industry experience, is the dynamic nature of the client. The client, the king or the queen, right? So I can talk the whole day just about the client, the nature of the client, but but to restrict my enthusiasm to talk about the client to just a couple of points. The first thing is the client doesn't know what they want. Doesn't know what doesn't know what they want. They or sometimes, or most cases, they feel that they're communicating what they want, but oftentimes it happens that we, being too technical in nature, because we keep dealing with Python architecture, right? So with that technical mindset, it becomes very hard sometimes for us to even understand the sense. You see the sense when I said, hey, obviously Geico is expensive, right? So that business sense. We sometimes are not able to capture what the client is trying to really ask. There's a real ask, and then there's a superficial ask, which they feel sometimes they just want to ask for something else. But it's always the real ask which you have to dig through, and that again will come through experience. You shadow your business analysts in the team. You shadow your directors and executives in the team, and you see how they probe the client, in a good way, of course. How they probe the client to get the information that needs to come to people like me. the requirement specs, right? Because there has to be a middle layer which has to talk to the client and understand their specs, freeze them, which is opposite to what I've written on the screen, which is dynamic nature, freeze them, and then give it to us so that we can work on the deliverable, all the data engineer, data modeling, data visualization, package it, send it back to the client and say, there you go, this is what you asked for. Then the client comes back and says, this is good, but you know what, our budget got cut and we don't want this, we need a different dashboard, right? And you're like, okay. So you can see it two way. Glass half full is you get more work, so you get more money into the organization, you get more money into the. The glass half empty is if the specs would have been clear at the first get go, we would have done that itself rather than doing this rubbish. So this is the dynamic nature of the client, and you have to live with it. You have to learn to adapt with the ever-changing requirements of the client. This will happen, and that's good. That's good in a lot of ways because you evolve, because you would realize that you probably did not ask the client the right question in the first place. Maybe you introspect and you realize that, oh crap, I should have asked the client, is this the database they wanted? I should have asked them before I even made that decision of choosing a specific database for this project, right? So these are the things that about the client that you need to really keep in picture. Again, a client will only come into picture when you are working either as a business owner or on an industry. But again, from an industry point of view, you have that safety net. Again, you have your colleagues and you have your executives who can help you, who can support you. They'll give you the decks, they'll give you some talking points or all these things to help you evolve in this role. So it's and any job, my dad always used to say that make sure that you're always client facing. Your job is always client facing. That is where the meat is. This is try improve, work on the skills if you can, work on all the skills that you feel where you have gaps, where you can learn to interface with the client directly. That is where you get to learn, and eventually down the line, if you feel that I'm done with working, I'm done with speaking with the clients, I'm done with everything, I know everything to start a business on my own. When you get out of this work culture and then you start a business on your own, the clients are still the same. In the sense, the psychology, the requirement of the clients, the people, they're still the same. But what you have learned a lot of things, a lot of experience that you have gathered by being in that type of work environment. So that's why I keep emphasizing on the importance of work experience. The next is, just like in any game, there are resources, and resources are limited. And in game, at least you have second life when you are dead. But in job or if you delete a database, most of the times there's no coming back from that. So there are limitations of resources, and by that I mean, when I say resource, it's a very controversial term in organizations, because humans or people, employees like me, are also referred to as resources, and sometimes people don't like to be called as a resource. But that's okay. That's all right. For the next 5 minutes or so, let's accept that definition. Okay, we'll protest later. So limitations of resources. They could be technical resources. They could be goof ups. They could be you only know matplotlib, but the client wants cbon to be used. You only know Python, but the project requires R. You know Google Cloud, but the project requires AWS. So there are a lot of dimensions when it comes to resources. So we'll look at all these dimensions one by one. So I'll start with time, and somehow technology also queued automatically. So time. It's very obvious. Time is the time that you need to do a certain job is most probably you won't be provided with that. So you need to that is a challenge. And if you're not in a specific work environment, if you're not thrown in that pool, like if you're just sitting at home, you have your own business, and if you don't restrict yourself with time, you're losing a lot on value and quality, and lethargy sets in. It corrodes your knowledge and your skill. So time is a very important resource, and it's often limited in work environment. And you need to and since it is limited, and you have to fight in getting more time to work on your code and stuff. This is where your negotiation skills with your project managers or the clients, or negotiation skills with your own manager who keeps pushing, no, you have only 10 hours to work on this, but you keep saying, no, I need 15 hours. So let's talk, let's understand. And this process is very important when it comes to jotting down your level of effort for every task required. If I ask you, how long will you take to create a VLOOKUP, or sorry, not VLOOKUP, build a pivot table out of a given data set, you should know how long you will take. 15 minutes, 30 minutes, 1 hour, it's okay. I'm not judging you how long you will take, but you need to know how long you will take to do certain tasks. And when you break all these tasks down, they accumulate into project tasks, right? Or master tasks, right? And they keep piling up, and they keep and this level of effort is what you need to know all the time. It's very important, and it's limited. Technology, I already spoke about technology. So you're faced with a lot of challenges. You have to work in a specific work environment sometimes, not all the time, sometimes, and you have to learn to adapt to that technology and work environment. So it's important. And the support, probably the teammate or the client or whoever is responsible is on leave, is on vacation, or probably is present but also does not have the same skill that is required for the project, which you also lack. You don't know how to plot let's say you don't know how to plot a bar chart using matplotlib. That is the project requirement, and your colleague also doesn't know. So limitation. So I said that you have your safety net, you have your colleagues and everything, but that is also sometimes you need to be practical, right? Sometimes not everyone knows everything. So that is also a challenge, and you will learn how to deal with these challenges. Like I always say that, right? There's speed breakers all over the world. Speed breakers are there, and everyone, whether it's a Ferrari or whether it's a truck, or it's a container truck, or it's a car, everyone meets at that speed breaker. Everyone stops at that speed breaker. Now, those are the challenges, those are the limitations. But once you cross that hump, it's the pickup speed of that vehicle that matters. Whether your big truck will too slow in adapting to change and picking up, or are you fast like a Ferrari car that after you're over the hump, you just zoom, you just fly. With okay, I am, let's say again, it's a hypothetical example. I am a GCP expert, but all of a sudden I got thrown into Azure. Ferrari, do you want to be a Ferrari, or do you want to be a huge truck, right? So it's very important to understand that there are limitations, but it's your pickup speed that matters. So that's about a quick summary about importance of industry experience. We just saw the importance of industry experience and how important it is in shaping your career. I hope this brief glimpse of industry experience has given you some understanding about the importance of business acumen. Remember this Venn diagram. I told you that computer science is something that you can learn from anywhere. Math and statistics, I don't have to teach you. You can learn from anywhere. Probably already know. And we are here to talk about business acumen or business expertise. And I hope part of the industry experience has helped you understand. So just give me a minute. We are almost done with the presentation. So let's quickly talk about business models. When it comes to, in my experience, my data science work experience, let's talk about that. and probably you can see if you can align yourself with based on your personality or your need or your likes. If you can align yourself to a specific business model that works out for you. So there are two primary business models that I usually say. They are service based and they are product based. Two types of organizations or two types of companies, or business models. Of course, the third one is you have your own business or you freelance or you contract your own contract jobs or whatever you want to call whatever you are, whatever you want. but we're not here to talk about own business or freelance. Again, you can go to data science dream job, I guess, datasciencedreamjob.com, and you can learn more about those kind of things. You can probably Google also, you can learn. But let's understand what the current country in the companies and the upcoming startups and companies are trying to cater to the needs of the people, or clients, what they're trying to cater to, and what are their operating business models. Again, I won't get too much into the business models. If you are interested, just drop me a note and I'll be happy to chat about it. So service-based is where how I would like to define it is that where you sell. Again, let me slow down. Service-based is where you sell your brain power for money, right? So that probably sounds a bit harsh when it's a brain power, but still that's it. You are a consultant. You know stuff, and people contact you because you know stuff, and then you tell them that this is it, this is how it is, and maybe they ask you to do it, you do it. You provide service, right? So companies like Ernst & Young, Deloitte, Wipro, Cardinal Path, for instance, my current organization. All these are service based. They provide services to people, and we are consultants. They consult us because they feel that we know a certain thing that they need help in, and they're ready to pay money for that. There are pros and cons for this. Again, this is a personality which, if you want to get into these kind of roles, your career path will be something like you are a staff. You're a staff consultant. Then you join as an associate or a staff, and then you become a consultant. You go into that role. You start. The way you evolve in the role is the amount of decision making that you do reduces. Let me rephrase. Your amount of decision making increases is what I mean by when you evolve in a certain role in certain space. So you're an associate, you ask your supervisor for everything, right? Hey, can I send this email? Hey, I've done this, can I send it? Do you think this is good? Do you think this looks good? Do you think I have drafted the email? Do you think I can send this? So these are the roles that the beginners have. And then you grow into consultant where you make your own decision. You can send that email. Probably not to the client directly, probably internally, your senior consultant will send it to the client. So that the next role is senior consultant. You probably interface with the client directly, and then you become manager or principal consultant. If you're a manager, it means that you're growing into a managerial role. If you want to grow into a technical role, as in I'm an associate cloud engineer now, a professional cloud architect, and now I'm a professional data architect or data engineer, and now I'm a big data specialist. I am this specialist, that specialist. So that is your technical role. You can grow into your technical role, or you can grow into a managerial role. So from senior consultant, your career path becomes into two. So you can choose one of them depending upon your personality and needs. I feel I'm not a people person. I feel that if someone comes, a subordinate comes and asks me, hey, can I take 2 days vacation next week? I wouldn't be in a position to say yes or no. So I feel I'm not good in that right now. So I am growing myself into the technical field. I'm trying to improve my technical knowledge as much as possible so that I can grow into that role. And when someone knocks at my door, I can fix that problem for them. That is what I'm doing. So you grow into the technical role. You are from senior consultant, you are a principal consultant, and then you are senior consultant, technical consultant, or principal consultant, whatever you want to call that. And then you are on your way in becoming a CIO or director or CIO. And from managerial path, again, manager, senior manager, associate director, senior director, president, vice president, whatever these roles are. That's how you grow into that role if you're a people person, because you know data science, you know that you can plot. Someone in the world can plot a bar chart using matplotlib, so you know that, but you don't want to do that. You are good at delegating that task, and you want to talk to the clients more about the business thing which I talked about. So it's up to you. You can try to grow into any of these roles. So that's more of service based. Um, Product based is you have your Facebook, eBay, Zoom is product based, um, Angry Birds is product based, Amazon as in the Amazon.com is product based. All these are product based, meaning when you're in a team, you are if you're hired as a data scientist, data science, whatever, you're hired into, let's say, Facebook, you would most probably be responsible for, let's say, analyzing, doing NLP on certain flagged messages, because people are talking about fake news a lot, and you have done your research in your academia on text analytics. You have done your research on NLP, so Facebook hired you to improve their product, right? So your brain power is used within the organization. It's not going out of the organization. There's no other client. Your client are your users itself of the product, one product, right? So you work on one product. You're probably building a chat bot in Skip the Dishes or something like that. So again, your data science skills are being put to use for that chat bot. You are only working on that product. And what happens in that is your team becomes like a small family, because all of you are brought in together to work on just that one aspect or one long running project. Let's say you have built a chatbot, now you've moved on to the next product or next element of that product, but you're still within the same organization. So that's where you see a lot of in companies like Microsoft, or people stay in the company longer because they grow with the product. I would kill to work for Valve or Blizzard, because I want to understand their work culture and how they build such quality products. Right? So just for temporary, of course, not for longer time. So these are the choices that you have to make when you want to decide whether you want to be a consultant who is known for a certain thing, with disconnected with the world, or disconnected with your colleagues, or disconnected with your any social aspects of your company. If you are that type of personality, you'll be a very good consultant. But if you're a more emotional person, or if you want to grow more into, you want to invest your personal time into the work that you do, you want to kind of blend everything together, product based is probably a. But again, whatever I'm saying is not the final, it's not cast in stone. Uh, this is what I have experienced, this is what I've seen across the world. So across my work experience, and my journey. So if any of these things suit to you, here's an activity for you. And you don't have to do it right now, but this is something which I would like you to do, and probably leave it in the comment section of the meetup page, or probably message me on LinkedIn. I want you to consider 3 dimensions: technology, industry, and career track. Again, I'll be briefly talking about that. And then I want you to write down in 50 words or less your 10-year down the line story. You would know that, again, you have to pass through different checkpoints when you're applying for job, right? So recruiter is one, then a technical round that happens, and then there's a peer review, and then there's a managerial round, They see a cultural fit and team fit and all those things, and then you get into a company, right? Obviously, you would have learned different things along the way, but I would also like to see if you can share your 10 years down the line story. Now, in that story, before you start writing that down, I want you to think about three aspects: the technology stream that you want to pick. I'll talk about that. The industry which you want to be in, and then the career track which I talked about, like this, right? With funny hand and gestures. The technical, this side was technical stream or the managerial stream or whatever other streams there are. So the technology, by technology, I mean a lot of things. I mean math, I mean R, I mean Python, I mean PostgreSQL, DB, I mean MySQL, Oracle, IBM, Microsoft Azure, everything. I want you to, if not now, probably take some time, try to understand everything, and then write this story. Try to understand what vendor do you want to pick, what technology do you want to pick, what do you want to do eventually 10 years down the line. So which technology do you want to be in? Industry, oil industry, energy utilities, healthcare, banking, finance, gaming, whether you want to, whether when you see that 15% off on a certain store, on an e-commerce platform, why 15%? Why not 10%, or why not 16%, or why not 20%? Why 15% off? Who gave that 15 number? It's probably coming from a team of data scientists. I'm not saying data scientist, I'm just saying it's probably coming from a team of data scientists. So does that excite you? Does that industry excite you? E-commerce, all the industries. Search all the industries available and pick which industry you see yourself in. And then the career track, obviously, I spoke at length about it. So keep all these things in mind and write down your 10-year down the line story. Keep this as your sticky note and try to work towards it. I have given you all the skills that are required for data science. I've told you how the industry experience is like. And of course, Google is at your leisure. YouTube is also at your leisure, so you can Google all these things, and you can let me know what you think about or where you land. So that's about it, and I think I can open the floor for Q&A, and let me know. So there you go.
Any questions for our guest speaker today?
Thank you very much. This was a very enlightening presentation. With your permission, I'd like to share my screen, and I'll share one slide. And I'd like your opinion as well as that of the group. Okay, so you have to allow me to share, please.
Oh, yeah.
Because it's disabled.
You can try doing it now. And I guess Pragith will have to stop sharing his screen.
Oh, okay. Is that so? Okay, let me see. Is everything okay now?
Yep. So I'm in the healthcare profession. In fact, I'm a surgeon. And I teach at our medical school. And one of the most difficult aspects of my job is to teach the medical students and the residents how to gather the information and the history, the physical examination, the labs, and so on, and come up with a diagnosis. I will give you a very simple example, and from there you can expand it to all the field of medicine. You have a woman in the age bearing, in the childbearing age, who presents with pain in the abdomen. And we're only going to consider two possible diagnoses: acute appendicitis, which everybody knows, ectopic pregnancy, meaning she's pregnant, but the baby is not in the uterus, it's in the fallopian tube. Ectopic pregnancy is a deadly disease. If the diagnosis is missed, the woman dies. Acute appendicitis is also deadly, but it's not as bad. Here are some statistics on the history, the physical findings, and so on. Even seasoned surgeons will make the correct diagnosis in appendicitis in 60%, and the seasoned surgeons will make the diagnosis of ectopic pregnancy in about 70%. And this is the incidence. The fever is 25%, not 250%. And this is the incidence of all the others. Can you devise an algorithm or a program that will say, okay, we will feed the information that we gathered at the bedside and can improve the correct diagnosis? And if so, how would you go about it, and who would be working on this project? And I'll stop. If you want, I can keep it up, but I'll turn it to you and you can take it from there to.
Yeah, sure. So before I discuss how I would approach these kind of problems, I would like to open the floor first. I would like to see if anyone else has any of their approaches before I share mine. So let me know. Just unmute, and you guys can start talking if anyone has any reply for Jacques.
Hello, I have a question here.
Please go ahead.
Yes, in the case of this pregnancy, can we just run a pregnancy test?
Yes, and you can see here under the third bullet, lab, pregnancy test is not always positive. And even if it is positive, it doesn't mean that this woman does not have appendicitis. Like a woman who is pregnant could still have appendicitis. It's perfectly legitimate, it's very possible. By the same token, a woman who has an ectopic pregnancy may have a negative 40% chance she has, 40% chance that she has a negative pregnancy test.
Okay, so so I can, so Jacques, I can tell you how I would typically approach these kind of business problems, and I've tried to keep it as generic as possible because I am not familiar with the medical terms and usually all the anything to do with healthcare. but I will try to keep my response a bit generic in addressing these types of problems. Yeah, please go.
Yeah, it doesn't matter whether you know medicine or you are,
exactly.
Let's say you're producing widgets.
Yeah, sure. Yeah, exactly. So I will try to I'll try to address. So what we do typically in these kind of business problems is when we hear the clients telling us this is my problem and how would you approach it. Our typical flow is discover, analyze, model. Discover, analyze, model, and produce. So these are different stages which we take when we approach a business problem. So the discover phase would be to understand what the available data is, whatever data in whatever shape or form, even if it is in books or even if it's in Excel files or whatever it's in databases. We try to understand whatever the available data is for addressing a specific business problem like this one. The second phase, so first level checked. Like once we are done with it, we see that whether we have how much amount of data to proceed with addressing this problem. And then we make a call whether we have to proceed or not. If we don't have all the available data, we have to probably say no. And sometimes it's good to say no. So the next phase would be to analyze. So we use all statistical tools. We build a confusion matrix. We will build. We'll use all sorts of analysis that can be used for with the available data, and then we will do these kind of, you said like someone who is part of this Venn diagram can be or cannot be part of this Venn diagram, and then there are all these percentages, right? So these probabilities and percentages which fluctuate. So all these parameters go into the analysis phase. So I am not familiar with the algorithm names or the approaches. Sometimes you have to use one or more of well-known algorithms. Sometimes you have to come up with your own algorithms. By algorithm, I just mean sequence of steps. That's it. Sequence of steps that can solve your problem is what I mean by algorithm. So then at the analyze phase, we come up with the algorithms, and then we build the model. We build the model, which after understanding all those things, we take only the required data from the discover phase, and then we push it to the model, and then the model will run across our algorithm, and then it gives us the output. Unfortunately, I won't be able to give you the exact solution to this problem, but at least these nature of problems, we face these kind of problems a lot. Like you said, it need not be just medical stuff. It could be anything. So we do deal with similar things with different stuff. And this is the exact approach that we take, which I just told you. This is what we do. So yeah, it's all about the data analysis, and then in a very structured way, building a solution for a problem. But I can only say that this can be done. I can't probably say how, but I can only say that this can be done.
Thank you very much.
Yep. Any more questions? Any more doubts from my meetup content? For those of you who are joining from India, or if wherever it's very late, I hope my soothing voice put you to sleep. Or at least I hope my voice is soothing.
Hi Pratik, this is Rishi here.
Hey Rishi.
First of all, it was a great meeting, and it has given a lot of knowledge, especially for freshers like us. But my question to you is, Pratik, as you talked about industry experience, okay? But what about a fresher student who has been from a management background or from a business background, and he all of a sudden comes to a data scientist or a data analyst background? So, I've been looking out for this kind of jobs on LinkedIn and different platforms, and I've been looking out for the organizational requirements. And I've been analyzing and seeing that they require a lot of experience, like minimum 1 or 2 years of experience to get into such fields. So I want to know is what kind of measures or what kind of steps you would suggest for a fresher to get such kind of jobs.
Yeah, very good question, and it's actually a frequently asked question. Someone who is in a certain role or is coming from a certain job academic background, and how they can, having gone through a sequence of learning processes of learning certain skills and tools, how they can get into data science roles, right?
Yeah, exactly.
And I can understand the problem, because it's a loop. If I'm going to interview you, I'm going to ask you what is your experience, and you're going to say I don't have any experience. So I'm going to say, okay, let's stop talking. And then and since you don't have experience, you can never work. So you're in that loop. I've been in that loop before, so I can totally understand. I can totally understand your situation there. This is what you can do, and thanks to the nature of the tools that we use usually in work, being open source, the nature of those tools being open source and free, what you can do is build a portfolio of yourself. Now, what would a photographer do? If I have to hire you for an event, and you are saying I'm a good photographer, hire me, and I would be like, okay, show me your work. So what would you do if you are a photographer? You'll probably show me your Flickr album. You'll probably show me your printouts and all the things that you have done, all the good names that you have received, and all those things, right? That's what you do if you're a photographer, right? And then I should get convinced with your work, even though you have zero work experience as a photographer. You didn't work, you just took photos of random things, right? But depending upon the quality of the work, I could be one of those persons, because that trend is evolving. So I am one of those people who looks at side projects, pet projects, and then judges them accordingly based on that, right? So thanks to the nature of the tools, which is they're free. Python is free, R is free, all the libraries are free. In fact, anything with MIT open source library, it's free to even make money on top of it. I think, yeah, without any without giving credit to anything, I guess. So there are a lot of things that you can do just by sitting on your bed. You don't even have to get out of your bed to create an impact for yourself. And then wherever you go, the first thing on your resume can read, this is my GitHub link, rather than, of course, like a Flickr link, right? Yeah, this is my GitHub link. These are my top 3 projects. This is what it is. You can make your resume look like your pet projects, your seriousness. The amount of seriousness that you've shown to your pet projects, if you show it to your resume, that of course, that doesn't suffice for industry experience, but that at least shows your seriousness. And then it's all about you or the person, right? How you talk to the recruiter, how you talk to the rest of the members, how you work on other skill sets, the communication skill sets, the presentation, the STAR way of talking, situation, task, action, response, or something. I'm missing the R, right? STAR way of addressing something. So all those things, that's what data science, right? But that all those things, what you talk inside that, you can talk about the pet projects also. So that shows me, compared to another profile which just says, I am interested in, my career objective is to improve myself and my industry, rather than just that profile. If I can see a profile which doesn't have any work experience, but at least has shown if not equal, but at least that enthusiasm of at least good quality work in GitHub and other places, articles, writing blog articles, showing your work should precede you. In short, I should know about you before I talk to you, and that can only happen when you show me your online presence. So make sure that you work on your, and that will just eliminate everything else. I don't care what your academic background is.
Okay.
Right? And don't make your other academic background as a weakness when you're applying for data science related jobs, because use it as a strength, because everything, any academic or non-academic knowledge, any knowledge fits under the business acumen Venn diagram, right? That circle, it fits under the business acumen. So prove that you're very good at that, and you're getting in the other two circles. You're getting there. So prove that. If you can prove that, that's it. Done. All good.
That's good. Thank you.
I hope that helps.
Yeah. Thank you.
Mm-hmm. We have 6 more minutes. Aditya, is that correct?
Yeah.
Yeah.
Anyone else with any questions? Maybe a couple more.
Either everyone got everything or everyone got nothing, right? That's okay. Just kidding.
Well, I had a question for you myself. It's probably a little bit off what was covered in the presentation, but there are basically 2 groups of, I guess, believers. One who think that a data scientist should be someone who has like a complete PhD and postdoctorate and whatnot to actually be relevant in the field. And there are others who think that these academic people don't really do a lot. They just the research may not be as reproducible as like working on actual code or something like that. So what do you think about like a data scientist academic versus data scientist industry?
Yeah, good.
What's your opinion on that?
That's good. That's a good question. Again, for everyone else, this was not a plugged question. This came out of Aditya's mind, honestly. This was not plugged anyway. So, well, the discussions are all fluff. All the discussions that happen on Facebook or LinkedIn about these things, they're all fluff. the cherry, the essence is in the work that you do. Everyone is required. The PhDs are also required. The students of those PhDs are also required. The people who are like Rishi, who are coming from management background, are also required. Someone else coming from electronics background is also required. Everyone is required. Everyone can be. There's an article, right, that that Lord Buddha was a data scientist. So you really cannot say like put it's a preference. And at that time, what happens is, if you're depending upon the amount of seriousness or intensity you show towards the field, the more serious jobs you get and more serious projects you get, right? So if you want to work on a self-driving car, you need to move past Matplotlib, right? But if you just want to help small businesses derive small insights, still meaningful, small does not mean not meaningful, still meaningful insights, and you're working on small data, where even using advanced analyzer in Excel, the analyzer add-in in Excel can also be, solve the purpose. You're still in the same umbrella term of data science, right? So you're still giving meaningful insights out of the client's data, and you're making them happy. At the end of the day, it's all about making the person who reaches out to you for help, making them happy. Whether it's client or whether it's yourself or whoever it is, it's just making them happy. So if you want to work for Elon Musk, probably PhD. Probably that is required. But if you just want to build a small chat bot or something like that, probably still yes, but probably with not that much intensity, right? You could opt for. So everything is there. It's all there. All the ingredients are there. You can use Cloud ML, Auto Cloud ML, whatever it is. Use AWS thing. All the ingredients are all over there. You are the chef. You just have to pick them and prepare it for the client. So if you guys still have any other questions you probably don't want to ask now, you want to ask later, please feel free to message me on LinkedIn. If you have any feedback about the presentation, anything you want to chat about, do drop me a note.
Yeah, again, thank you so much for agreeing to do this for us. And although because of the lockdown we can't physically meet for such meetups, it does give us the opportunity to reach out to people like you who are not really inside the city but still can provide us with great insights like these for what is now being called the sexiest job of the 21st century. So thank you from our behalf for doing that. And yeah, thank you everyone else for attending as well. And as he said, you can ping him on LinkedIn if you had any other doubts. And yeah, that's about it from our side. Thank you so much.
Thanks for having me here.